Good morning, folks. I'm Sushil Srinivasan. I'm the product manager in charge of CloudLens Public. That's our public cloud visibility solution. So let's go ahead and get started. So we've seen how data has been evolving over a period of time. Earlier in your traditional data centers, everything was under a single infrastructure. So you can have your taps, you can have your bypass switches. Then using those, you can pull the traffic in, you can bring it into your packet brokers, eventually give the traffic to the tools for further analysis. But now, data is distributed, especially in an environment where you have virtualization, where you have public cloud, different flavors of public cloud. Data is so diversely distributed that bringing in visibility in this sort of an environment becomes a significant challenge. So what CloudLens does is it brings information, it brings this packet level data from different silos, whether it resides in your virtual data center, whether it's in a private structure, whether it's in a branch office, or in a public cloud, or if it's in multiple public clouds, we don't care where it is. We can bridge this gap. We can remove these blind spots wherever they exist. If it's within a data center, we can remove the blind spots. If it's across public clouds, we can still remove those blind spots there. And we bridge and bring in all this packet level data visibility into the tools which rely on these packet level data. So let's look at what CloudLens is. So CloudLens actually it is a platform. So we have our private cloud infrastructure, we have our public cloud infrastructure, and we have a cusp of those two bridging together, which is the hybrid cloud solution. So for the private cloud, as we discussed earlier, we have our virtual taps, virtual packet brokers. These are actually virtual appliances which run on a hypervisor. So these basically sit on a hypervisor. It monitors the virtual switch fabric, whether it's an open vSwitch in a KVM environment, or if it's your VMware ESXi hypervisor, then we look at the VSS or VDS, depending on how the traffic comes. We tap the virtual switch, we bring in the traffic to a packet broker where advanced packet manipulation can be done, and eventually it can be forwarded to the tools. Now, for the public cloud, we did not take a traditional lift and shift approach, where you package an existing solution that works in your on-premise data center and move it into the cloud and expect the same level of information to be delivered in the cloud. What we did is we re-architected a complete new solution for the public cloud. We built our public cloud solution using cloud native services. We built it using a serverless design. The primary objective for this is to address cloud scale and solve the problems that public cloud primarily poses. So let's look at what are the challenges using public cloud, right? The primary problem is in the public cloud infrastructure is you do not have access to packet level data. The primary reason being public cloud service providers remove certain conventional tools which the private data center has access to. For example, your layer 1 and layer 2 is completely not available to you in the public cloud. In a layer 3 infrastructure, you still have certain limited swim lanes which the cloud service provider offers you. Taking the example of AWS. So by default, when you launch an instance in AWS, you launch it within a VPC. A VPC is nothing but a specified segment of IP addressing schemes, and you are given access only to that specific IP addressing schemes. Even within that, you don't have access to your default gateway. You can manipulate the default gateway, but still that causes another separate set of problems. You don't have access to multicast addressing schemes. You'll have limited access to broadcasting schemes. So these are all challenges from a packet level perspective, from an IP layer 3 level perspective, in bringing that level of information to your tools, which require those information. Looking at the second problem, the primary objective of customers moving to the public cloud is elasticity and scale. You are capable of bringing in your infrastructure or bringing your infrastructure up and running within a few seconds. In a private data center, it's going to take a long time for you, especially to bring up a physical device, bring up a physical server, launch it, and get it up and running. In the cloud, you have it running within a few seconds. Now, that becomes a challenge because your traditional infrastructure related policies that you had are no longer relevant to the cloud. Looking at an infrastructure churn, now that kind of works in conjunction with elasticity and scale. When you have your instances which are scaling up and down dynamically, those policies, those visibility policies that you had written for your private data center, they are no longer relevant. For example, if you have like anything related to a VLAN, so that's no longer relevant in the cloud. And even IP addressing scheme, because of this infrastructure churn, IP addressing schemes which are associated with an instance at a particular time, at a time delta t, they might be associated with a completely different instance doing completely different things. So how do we bridge this gap? How do we eliminate these blind spots? And how do we solve this problem? That's exactly what CloudLens does. So let's look at what CloudLens is. So there are two components which work together to bring in visibility in the public cloud. The first one is actually a software as a service management portal that is built using cloud native services. It's built using a serverless architecture which runs in the cloud. The second component is a Docker-based container for Linux instances, and it's an agent-based solution for Windows instances. So these are the two components which work together to bring visibility in the cloud. What are the advantages of these two instances, right? Let's look at the bottom part first. The advantage of using a container or a sensor is that it gives us the flexibility to be cloud service provider agnostic. So anywhere a container can be installed. If it's a Linux instance that's running, anywhere a Docker container can be installed, our solution can work, whether it's Amazon Web Services, Azure, Google, IBM, Alibaba Cloud, you name the cloud. Even if it's running on your laptop, we can install a container and we can bring that visibility into your infrastructure. If it's a Windows-based solution, the same thing applies. If all we do is install an agent, we can bring in visibility into that. Now, with a container-based solution or an agent-based solution, because we reside within the workload, any security policies that are associated with this particular workload are automatically ingested by us. We don't need to worry about adding any new additional security profiles or policies for our solution. The advantage of using a SaaS-based model is that it's highly available. All you do is log in into a web portal. The only thing that's required is access to internet, and you have our solution, our management portal readily available to you. So these are the two components which work together to bring in visibility into the cloud. Now let's see how this actually works. So as a user, you log in into our SaaS portal, and the blue box there is actually your primary source that you want to monitor. So you have multiple applications which could be running within that source, and you have 3 different tools which you want to send the traffic to. So you have your production traffic which goes out into your production network, irrespective of which cloud infrastructure it is in. What we do is we install our containers or our agents depending on what sort of a tool, what sort of an instance that is. So once CloudLens containers are installed, we get information about the rich metadata information about what sort of an instance it is. For example, like which cloud service provider it's running in, which regions it's operating in, how much of memory it has, how much of CPU it has, what specific applications that are running in it. So all this rich metadata information is available, and it's sent to it's phoned home to our SaaS portal. Once that is done, from our SaaS portal, we basically can create advanced intelligent filters right at the source and send relevant traffic to relevant tools. By this, we eliminate unwanted traffic, unwanted infrastructure-related traffic right at the source. Only the traffic that's of relevance to you gets sent to the tools. So this is how our CloudLens solution works. Now, what you're seeing right now is basically how you can bring in traffic from a single instance, and you can send it across to multiple tools. But in a cloud infrastructure, we are talking about hundreds of workloads, or hundreds of thousands of workloads. So how do we do that? So this is how we operate. So this is the workflow. Based on the metadata that we ingest, we allow the users to create what's called intelligent grouping algorithms. Let's take an example here. So let's say you are running a web service and you want to use an APM tool to monitor your web service here. So based on the characteristics of your instance and the metadata that you ingest, you create these grouping algorithms. You create the source group which says, hey, this is my source group, which is nothing but web services. Similarly, on the tool side, I want to send traffic to my tool, which is an APM tool. So you will group the tools together as another group. And with a simple drag and drop, what we do is we create this peer-to-peer VPN tunnels from our source groups to our tool groups, which just brings in traffic. So this is a simple 5-step process to bring in visibility in any cloud infrastructure. So this is how we work, right? As a user, you log in into our SaaS portal, you install our CloudLens containers within your source and tool instances. Here in this example, what I've done is I've grouped my 3-tier architecture as separate app, web, and DB groups on the source side. On the tool side, I want to send the traffic to my security, my APM, and my health check group. So with a simple drag and drop, I create this peer-to-peer VPN tunnel. Now, I can send information from one group, one source group to multiple tool groups, or from multiple source groups to multiple tool groups. It's like a many-to-many relationship. It's what we support. Now, the advantage of doing this, or the advantage of embedding our solution within the instances, is that it gives us the flexibility to scale. Now, as and when your sources and tools scale up, as long as they have the same characteristic of the existing groups that you have created, we automatically add them to the group. Let's again take the example of the web server, right? So today, if you're running 5 web servers, on a regular weekday running 5 web servers, on a Friday, you might want to up your web servers from 5 to maybe like 15 web servers. So that's a dynamic scaling which comes up, but there is no, what we do based on the solution that we have, there is absolutely no manual intervention that's required. As long as we know that it's a web server, we automatically add them to the web server group, and all the policies that you write for the web service group are inherited by these new instances that come up, and dynamically they start pulling in the traffic and sending it to the tools. Similarly, on the tool side, as and when your tools scale up, we take care of the load balancing the traffic that's coming in from the source instances to the tools. Now, the two things that happen intelligently is that on the source side, even if your sources or even if your workloads reside behind a NAT, or if it's in a private VPC, from a networking perspective, we take care of all the heavy lifting. On the tool side, we take care of the information based on how we load balance the traffic across to the tools. So this is how our solution operates, and it's primarily, if you see, this is basically solves your cloud scale problems. Now, two things to keep track of here is, the first one is there is absolutely no additional infrastructure which is added for visibility. We just work with the existing infrastructure that you have. There is no architectural change that is required. So we embed ourselves as containers or agents. Using our SaaS portal, we bring in visibility into an infrastructure. So this is how our solution works. Now, there are certain cases where tool vendors who may not be ready for the cloud, and they still may be running in your on-premise data center. How do we bridge the gap? How do we bridge the gap in a hybrid cloud environment, right? So what we do is we have our CloudLens solution, which can be installed on our packet brokers, on our virtual packet brokers, which run on hypervisors. So what happens is any information that's running in the cloud can directly be brought into our virtual packet brokers. From there, you can send it across to your virtual tools or to your physical tools.
But no, we do have a number of customers where, and this was surprising to us only because we thought that, well, that's a lot of data to be sent from the cloud to your on-premise tools. Now, of course, we don't have to send all of it, but we do have a number of customers where they say, I'm running applications in the cloud, but yes, I have a significant investment on my on-prem tools. So how can I still send the data? And of course you can. You can, absolutely, and this is what Sushil is covering. Now, given that we have an agent on every single data source, technically you don't have to send all the data. So it's not like you have to incur significant WAN cost or internet costs. You can still filter based on certain criteria, but then send those to your on-premise tools. And just to highlight, maybe it wasn't clear, but in the previous slide when Sushil was going over how CloudLens works, it's a SaaS-based offering, but it doesn't have to just monitor applications in the cloud. Those applications can be in your private data center too. So you can have private data center applications. It's still a Docker-based container. It will just still phone home to the SaaS portal. It will just say, well, I'm running on a private data center rather than the cloud. Again, the tools can be on a private data center, so it can be any combinations. The tools can be in the cloud, it can be on-premise. The data can be on-premise, or it can be the cloud. It really doesn't matter. It's just really a SaaS platform, and it can bridge the gap, no wonder.
Thanks, Vijay. So we introduced our MultiCloud support So these are all the cloud service providers which we can support today. So technically, because we are a container-based model and we are a SaaS and container-based model, it gives us the flexibility to be anywhere. So let me walk through a short demo of what are of how our product works live. So what I'm going to do is I'm going to log into our SaaS portal. I'm going to launch our containers in Azure, and I'm going to show pingcnn.com, and I'm going to show the same traffic coming in across into our tool, which is running in Amazon Web Services. Basically, it's a Wireshark tool. I'm going to show the packet data that goes in and out of CNN coming onto our Wireshark tool. Now, simultaneously, while this is happening, I'm also going to show IBM talking to Google Cloud talking to IBM. So basically, under one umbrella, under one SaaS portal, we're going to see Google Cloud talking to IBM, and we're going to see Azure talking to Amazon. So this is actually our CloudLens portal. And if you see on the left side, we have all the source groups, and we have different kinds of cloud service providers which are part of the source groups. For example, you have your IBM group, your Google, your Alibaba Cloud, your Azure, all these different instances which are running in different cloud service providers. On the right side, you have different tools which we work with. For example, you have Wireshark, you have Dynatrace, you have RSA's NetWitness, you have ProtectWise, we have open source tools like Security Onion, Bros, Circada. All these tools are available to us. So I have my different cloud service providers here. I have Azure, I have Google, and in Google right now I have an instance which is running where I have our containers operating. And from Google, I'm actually pinging nasa.com. If you see, I'm pinging nasa.com. Let me restart that right now. And I have IBM Bluemix here. Let me re-authenticate my session. And here I have 4 instances which are running. So this is the instance which we're talking about, looking at, which is 169, 54, 233, 100. So going here, so this is my instance, which is basically my virtual server 1. Now I'm just grepping on ICMP. Just give it a second. You should be able to see the traffic which is going in from Google Cloud. You should be able to see that in IBM. So you can see that this is my IBM server instance running in IBM Cloud, and I have my ICMP traffic coming in here. Now let me go back and do the same thing with Azure. So here I have my Azure group, and I have my AWS tool here. So all I need to do is just a drag and drop. Before that, let me just start the traffic. So this is my Azure instance, and here I want to ping cnn.com. So let it ping cnn.com, and what I'm doing is, so with a simple drag and drop, I create this peer-to-peer VPN tunnel from my source group running in Azure to my tool group which is running in AWS. So my tool, my link has been created, and it also gives me the flexibility to create filters. So for example, if I'm interested only in certain TCP traffic or UDP port traffic, I can create my filters right here at the source. So I can just say this is my ICMP traffic which I want to filter, or I can just say this is my TCP port 80 traffic which I want to monitor. So I can specify all the filtered traffic right at the source. Not just that, what I can do is I can create these links to go from a single source to multiple tools, and I can create separate filters on each one of those links. For example, one link which is going to one specific tool which is interested in monitoring, let's say, only port 443 traffic, I can filter everything else, send only port 443 to that. But I can also send the same traffic to another tool which pretty much requires, let's say it's an IDS tool, which requires all the traffic to be seen, so I don't need to put any filters, so it sends out all the traffic to that particular tool. So it gives us the flexibility to do all these things. So let's go back here, and now I'm sending traffic from my Azure to my AWS. So this is just a VNC session which I'm starting. So just give it a few seconds. And we should be able to see that here. Now, while that is coming up, I can also show, like, this is Alibaba Cloud, and I have a source which is running in Singapore region, and I have another source tool that is running in the Hong Kong region. And using CloudLens, which is running in our SaaS, I can bridge the gap. I can bring in the traffic from Singapore all the way to Hong Kong. So it gives me the flexibility to do that. And now you can see that the traffic that's going in from CNN.com, between my instance running in Azure to CNN.com, a copy of that gets sent to my AWS tool. So far, what we have seen is how we can bring in visibility from an instance perspective. If it's running in any cloud infrastructure, we can bring in visibility from an instance. Now, further down, we can talk about. I'll invite Chris Rainey to talk about how we can bring in visibility in from a microservice, from a container which could be running anywhere. How do we bring visibility into a container environment? Let me invite Chris to come and talk about our container visibility solution.